Example 8 sees another wrinkle that the AP writers like to place on the exam. What if we have a piecewise defined function? Okay, our function f of x is x squared if x is less than 1, and it's 3x minus 2 if x is greater than or equal to 1, and we're looking to calculate the integral from 0 to 3 of the function. Okay, well, the problem is that our function changes formulas right in the middle of our interval. So we have to integrate the function involving x squared while x is less than 1, and then we need to integrate the function involving 3x minus 2 once x is greater than 1. What does that mean? It means we have to use one of our definite integral properties from a previous lesson there, where we know that we can break up an integral into two separate integrals that are each a part of the whole. So in other words, we're going to start at 0, okay? And as long as we're less than 1, we can use x squared. So from 0 to 1, we're going to have the integral of x squared dx. Okay? And then we're going to add to that, and then we have our second integral. Now the second integral needs to pick up where the first one left off. The first one left off at 1, so we're going to start our integral at 1, which makes sense because the second function is valid once x is greater than or equal to 1. Okay? And our integrand is going to be 3x minus 2 dx. What we need is our upper bound. Well, the upper bound, we want to stop at 3. Right? So this is sort of a 2 for the price of 1. We have to break up the integral into two separate integrals, and then we solve each of them individually, and then we just merge them back together for a final answer. So let's go ahead and do that. With our first integral, we know that x squared becomes x cubed over 3 when we take the antiderivative, and we're going to evaluate that from 0 to 1. With our second integral, 3x will become 3x squared over 2. The 3 is a coefficient, so it stays. X antiderives to x squared over 2. The minus 2 will antiderive to minus 2x. Oops, I don't want that there, sorry. And we are going to evaluate that from 1 to 3. Okay, so we take a look at the first evaluation. We plug in 1, we're going to get a third. We plug in 0, we're going to get 0, so we have a third minus 0. Plus, now we plug in the 3. When we plug in the 3, we have 3 times 9 over 2 minus 2 times 3 minus, now we plug in the 1, so that's 3 times 1 over 2 minus 2 times 1. And again, this is a correct answer, which doesn't need to be simplified unless you have a multiple choice question. So if that were to be the case, we can see here that we have 1/3. And then over here we have 27 over 2 minus 6. Now 6 is 12 over 2, right? 12 over 2 here. So 27 minus 12 gives us 15 over 2. And then we're going to subtract from that. We have 3 over 2. And then 2 is 4 over 2. So 3 halves minus 4 halves is negative 1 half. 15 halves minus negative 1, and you see that we're adding double negatives, so that's 16 halves. 16 divided by 2 is 8. So 8 plus a third means we have a final answer of 8 1/3.